Hello students, welcome to third lecture of chemical bonding and molecular structure. In previous lecture we discussed about octet rules and covalent bonding, and now let's proceed further. So our next point is Lewis representation of simple molecules. So as mentioned earlier, we already discussed about symbolic representation of atoms according to Lewis representation, and now we will discuss about molecules. That means how we can arrange valence electrons in molecules in which we have more than one atoms. The Lewis dot structure provides a picture of bonding in molecule and ion in terms of shared pair of electron and octet rule. So keep in mind shared pair electrons and octet rule. We have to fulfill both of the conditions. That means you have to arrange 8 electrons around the each atoms except hydrogen, because hydrogen needs only 2 electrons because it will gain electronic configuration like helium. So remaining elements requires 8 electrons, and between two atoms at least 2 electrons must be present to form a covalent bond. So while such picture may not explain the bonding and behavior of molecule completely, it does help in understanding the formation and the properties of molecule up to large extent. Writing of a Lewis dot structure of molecule is therefore very useful. Lewis dot structure can be written by adopting the following steps. Total number of electrons required for writing the structure are obtained by the adding the valence electrons of the combining atoms. That means if we have two atoms in a molecule, then you have to count total number of electrons of valence electrons of both of those atoms. As for example, in CH4 we have total 5 atoms, 1 carbon and 4 hydrogen. So in molecule there are 8 valence electrons available for bondings, in which 4 belongs to carbon and 4 belongs to hydrogens. For anions, each negative charge would mean addition of 1 electron. For cation, each positive charge would result in subtraction of 1 electron from the total number of valence electron. For example, the CO3 2 minus ion. So in this ion, we can see we have minus 2 charge on CO3. That means in this case we have 1 carbon 3 oxygen, and if we count the total number of valence electrons of each, and then you have to add 2 more because of minus 2 charge. That means in this case, as we know, carbon has total 4 valence electron. So from the carbon side you will get 4 valence electron. In case of oxygen we have 6 valence electron. So in this case we have 3 oxygens, so total number of electrons from oxygen side it will be 18, and 4 from carbon, so we have total 22 electrons, valence electrons, and because of minus 2 charge you have to add 2 more electrons. So that means total number of valence electrons in CO3 2 minus will be 24. For NH3 4 plus ion, one positive charge indicates the loss of one electron from the group of neutral atom. That means let us count total number of electrons without any charges. So nitrogen contains 5 valence electron and 4 carbon gives 4 valence electron. That means we have total 9 valence electron, but because of plus 1 charge you have to remove one of them. That means 8 will be remaining. So NH4 plus contains total 8 valence electrons. Knowing the chemical symbol of the combining atoms and having knowledge of a skeletal structure of the compound, it is easy to distribute the total number of electron as a bonding shared pair between the atoms in proportion to the total bonds. So how can we find the skeletal structure? So it requires some basic knowledge of bondings and shape of molecules. If you gain that knowledge, then you can easily arrange the atoms in different type of molecules or ions. That means you can prepare skeletal structure by knowing or guessing. In general, the least electronegative atom occupies the central position in the molecule or ion. For example, in NF3 nitrogen will be at the center, in CO3 2 minus carbon will be at the center. But it is not true for all of them. In majority cases this type of situation will be observed. As for example, in case of water molecule, oxygen is at the center, That means more electronegative element is at the center. After accounting for the shared pair of electron for single bond, the remaining electron pairs are either utilized for multiple bondings or remain as lone pair. So that means if octets are not complete, then extra electrons will be used in multiple bond formation. That means either in double bond formation or in triple bond formation. And if octets are complete, then they will remain as lone pair of electron. That means non-bonding electron pair. The basic requirement being that each bonded atoms get an octet of electron. Lewis representation of few molecules are mentioned in this table. So first example, hydrogen. As we know, one hydrogen contains one valence electron. So hydrogen requires one electron to complete its outermost orbits. That means it will gain helium-like electronic configuration by sharing one electron with other hydrogen. Next, oxygen. So as we know, oxygen contains total 6 valence electrons. So it requires 2. In requirement for oxygen is 2 to complete its octet. So it will share total 2 electrons with adjacent oxygen or other oxygen. Between two oxygen, you will get total 4 electrons or 2 pairs of electron. That means double bond. So as we can see in the structure, here shared electrons are converted into bonds, and lone pair electrons are still present on their respective atoms. That means, as you can see, in this case we have total 4 electrons. That means 2 shared pairs and 4 electrons as lone pair or non-bonding electron pair. So shared pair are converted into bonds, and a lone pair of electrons are still present on respective oxygens. Then in case of ozone, to complete the octet, slightly different type of situation occurs. So as we can see, we have total 3 oxygens in case of ozone. Okay, so let us concentrate on first structure. So initially each oxygen contains 6 valence electrons. So total number of valence electrons, it will be 18. That means 6 from each oxygen. So we need to arrange total 18 electrons in total 3 different oxygen, and we have to complete octets of each oxygen. So as we can see, first, second and third, let us give them names so we can easily identify them. Between first and second oxygen, normal situation is being observed. That means just like O2 molecule, they will share total 2 pairs of electron. Okay, so nothing is unusual going between first and second oxygen. And you can notice around the first oxygen we have total 8 electrons. Okay, so that means first oxygen is satisfied. Now let us concentrate on second oxygen. As you can see, positive charge is mentioned on the second oxygen and negative charge is mentioned on next or third oxygen. So it means one of the electron of second oxygen will be shifted in third oxygen. That's why second is positive and third is negative. So electron of second oxygen is being used in the bond formation with the third oxygen. That means third oxygen do not provide any electrons in bond formation. As mentioned earlier, in covalent bond each atom should contribute in bond formation, but in this case third oxygen do not contribute in bond formation. That means it do not provide electrons. So both of these two electrons actually belongs to second oxygen. So these type of bonds are called coordination covalent bond, in which only one atom provides two electrons in bond formation. So this is the situation here between first and second oxygen. Normal situation is going on. Between second and third oxygen, second oxygen shares electron pair with third oxygen. That's why one extra electron is entered inside the oxygen because it do not share electron with second oxygen. That's why it gains one extra electron, and because of a shared pair belongs to second oxygen, it loses electron. That's why it is positively charged. Now concentrate on shared pairs. As you can see, here we have total 4 electrons or 2 pairs, and in this case between second and third we have 2 electrons or 1 pair. So that means these 4 electrons represents double bond and this 2 electron represents single bond. So that's why our structure will be first and second are double bonded, and second and third are single bonded, which you can see in adjacent representation. Next is NF3. Now nothing unusual is going on here. All of them are following exactly same rules. That means no coordination covalent type situation as mentioned in ozone or O3 molecule. Each atom shares one electron with adjacent atom, and all of them gains complete octet. Then we have CO3 2 minus. So as we can see, carbon shares total 2 electron with one oxygen and one electron with two different oxygen. That means with one oxygen it is double bonded, with two oxygen it is single bonded. And because of extra gain of electron, it carries negative charge. Actually, this negative charge will shift in all of these three oxygen. That means actual bond structure can be represented like this. With two oxygen, we have single bond, and both of these oxygen will be negatively charged, and one oxygen is double bonded and it will be neutral. Now, after a certain time, this bond will be removed, and here it will be placed, and now this oxygen will be negatively charged. After some time, this bond will shift here, so this oxygen will be neutral and this will be negatively charged, and so on. So repetitive process will occur. It is called resonance, and you will learn about it later. Then we have nitric acid molecule. So in this case, coordination covalent bond type situation is again happening between nitrogen and one of the oxygen. So you can guess with which oxygen nitrogen has coordinate covalent bond. So as you can see, on the nitrogen we have positive charge and one of the oxygen carries negative charge. So that means negatively charged oxygen do not share electron pair. So both of the electron present between nitrogen and negative oxygen belongs to nitrogen only. So based on the previous points, here problems are mentioned. Two different problems are mentioned here. Try to solve it yourself, and then we will discuss it in next lecture. First, try to solve these two problems, that means structure of CO and structure of NO2 minus. Try to solve it yourself, and then we will discuss it in detail in next lecture. If you find any difficulty, then you can ask me. Otherwise, we are going to discuss this point anyway.